Hello everyone, my name is Rahul Suryavanshi and today we will be discussing on how to design a washing machine controller using fuzzy logic. Before going ahead, let us just understand the block diagram approach of what exactly we are going to do in this problem. Now, first we will be selecting the input and output parameters. These input and output parameters are sent to the normalization block. Now, if the this normalization block is an optional block, so if the values are very large or very small, then these blocks will come into picture. Now, once the values are normalized, that is, the values are got on the scale of 0 to 1, then the values are sent for further processing, that is to the fuzzification block. Here, the crisp values are converted into fuzzy values. Once the values are converted into fuzzy values, this is further sent to the inference engine block, which is nothing but the heart of the system. So depending upon what are the input and output parameters, the rules will be getting executed and the entire computation will take place in this block. Now, the result of this block will be sent to the defuzzification block, wherein the fuzzy values are converted into the crisp values using various techniques, or using any one of the technique, which is nothing but center of gravity, height method, first of maximum, last of maximum, weighted average method, etc. Any of these values, any of these methods, whichever are applicable, are used in this block to get the crisp values, a single crisp value. Now, once we get the single crisp value, it is sent for the denormalization block. Now, if we have applied the normalization, then the denormalization block will come into picture. If we have not applied the normalization block, then denormalization will not come into picture. So once this part is done, then we'll be getting the final crisp output. So this is nothing but the entire flow of the problem. Now, coming back to the problem of washing machine, uh, there are we need to select the input and output parameters. So the input parameters what we are selecting are weight of the clothes, type of the clothes, dirt level, and the output parameters are quantity of water, time for washing. It is not only restricted to these input and output parameters. It can be, there can be n number of input and n number of output, depending upon how sensitive or how precise we want the outputs. Next, uh, once we have selected our input and output parameters, we need to select the ranges for these parameters. That means what? The maximum and minimum ranges for these parameters. Now, the input parameter what we have selected is weight of the cloth, dirt level, and type of the clothes. And the output parameter what we have selected are quantity of water and time for washing. Uh, let us come to the input part, weight of the clothes. When we are talking about the weight of the clothes, we have to see that what is the maximum weight that can be put into the machine. Now, considering an average domestic machine, these machines are of ranges of 0 to 5 kgs, 7 kg, and 9 kg, up to 15 kgs. And there are commercials also which goes on higher sides also. But for simplicity reason, from the point of view of domestic application, what we are going to take is the weight of the cloth as 0 to 7 kgs. So maximum weight that can be put into a machine is 7 kgs. Now, next, dirt level. The dirt level is categorized in terms of percentage now. It is 0 to 100%, wherein 0 stands for no dirt and 100% stands for maximum dirty clothes. So the dirt level is being categorized on the basis of percentage, 0 to 100%. Then the third one is type of the clothes. As the washing machine can be used for any type of cloth, that can be a cotton, silk, woolen, or it can be a mixture of any of these. So depending upon the type of the cloth, the time for washing, the type of detergent, then quantity of water, everything changes. So this is one of the important input parameter. The next is nothing but the output parameters. The output parameter is nothing but quantity of water and the time for washing. Here in quantity of water we are selecting the range of 0 to 100 liters. As we have selected the range for weight of the cloth as maximum of 7 kgs. What we have done is the maximum amount of water that is required for washing 7 kgs of clothes is 100 liters that we have considered. So 0 to 100 liter is nothing but the range which we have selected for washing of quantity of water. And next is nothing but the time for washing. What we have done here is we have selected the time for washing as 0 to 60 minutes. that is depending upon the weight of the clothes. It has been seen that zero is nothing but the minimum time, and 60 minutes is nothing but the maximum time that can be used for the washing. So depending upon the weight of the cloth, dirt level and type of the cloth, these parameters will be automatically selected. But as we are going to do this entire problem manually, for simplicity reason, we are going to select only two inputs and one output. That is nothing but inputs. What we are going to select is weight of the clothes and dirt level, and output what we are going to select is time for washing. Next, as from the block diagram approach, as we have said that the first block which comes into the process is normalization. But as we have seen that the values what we are using, the range what we have using is 0 to 7 kg, 0 to 100%, 0 to 100 liters. So as these values are smaller values, we need to we need not use the normalization block. If the values were in terms of something around kilo, mega, 10 raised to 4, 10 raised to 6, 10 raised to 9, or 10 raised to minus 6, 10, nano, pico. So if the values are very big or very small, then in that case we can go for normalization block. But as in this case, normalization is not required. So the next block what will coming into picture is fuzzification. Now, the inputs and output parameters whatever we have selected are in the crisp form. That is nothing but 0 to 7 kg, 0 to 100%, 0 to 100 liter. These are the crisp values. That is nothing but the human understanding numbers. But computer cannot understand this thing, so we need to convert these crisp values into fuzzy values. Okay, so for that reason the fuzzification block is there, which converts the crisp values into fuzzy values. Here, the first what we are going to select is the weight of the cloth. So weight of the cloth what we have selected is the range is 0 to 7 kgs. Now this weight, what we are going to do is we are going to subcategorize into three parts. That is nothing but low weight, medium weight and high weight. So the low weight is again considered, again the ranges have to be considered for it. So low weight is nothing but 0 to 3 kgs, medium weight is 2 kgs to 5 kgs, and high weight is 4 kgs to 7 kgs. Here we are considering an overlapping type of function. So you can see here 0 to 3 kg is nothing but the low weight, whereas the medium is again starting from 2 to 5 kgs. So 2 and 3, this area is a overlapping area. This has been done in order to get the precise outputs and to lose and okay. uh, Here, from the diagram what we can see is, this axis here we can see these are nothing but the fuzzy values. Y-axis is the fuzzy value and x-axis is nothing but your crisp value. So what we can see here is we have selected the triangular type of function, and the last one is an incremental function. Here, WL stands for the term sets. What we are using here is for low weight, we are using WL, where W stands for weight and L stands for low. So, low weight, medium weight, and high weight. Here, we are using the triangular type of functions in order to describe these values. So, 0 to 3 kg, we are using a triangular function. So, 0 is nothing but having a membership degree of membership of 0, because the weight is very low, so the degree of membership is also low, very low. So as we go on approaching towards 1.5, so 1.5, when it reaches 1.5, it has reached its peak value, that is nothing but 1. Okay, now as we move away from 1.5 to 3, we are moving away from low weight, but we are approaching towards the medium weight. So that's why this value goes on decreasing, whereas once it reaches 3 it becomes 0. Meanwhile what has happened is 2. So 2 is nothing but, when we are talking about 2, uh, in 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 medium category, the degree of membership is 0. So in medium, 2 is very low value, it is not considered. But as we go on approaching from 2 to 3.5, so the value goes on increasing, and then further again it goes on decreasing. Similarly, what we have done is we have taken for high weight, wherein it starts from 4, it goes on increasing till a certain point, that is till 6 kgs. It goes on increasing, that is an incremental function. But after 6 till 7, we have kept it constant, because 6 kg or 7 kg, it will not make much difference into the weight and time. Okay, so in that is the reason we have kept it constant. We have not used the triangular function because any value above 6 kg is considered to be a high value only, and this degree should not go on decreasing. So it goes on increasing and it reaches a certain value, that is 7, and then it stops here. So this is nothing but the fuzzification for the weight of clothes. Next, okay, the next input what we are going to consider is a dirt level. Here, dirt level is categorized in terms of percentage, that is having a range of 0 to 100%. Here also we have considered dirt level into three parts, that is nothing but low dirt, medium dirt, and high dirt, that is DL, DM, and DH respectively. Low dirt is categorized into the range of 0 to 40%, whereas medium dirt level is considered in the range of 30 to 70%, and high dirt is considered in the range of 60 to 100%. So here also we can see that we have used an overlapping type of function. So coming to the diagrammatic representation, we can see that this axis, that is nothing but y-axis, is nothing but your fuzzy values, whereas x-axis is nothing but our crisp values, that is D, that dirt level. So it is ranging from 0 to 100%. So what we have done is we have categorized them into a, so we are converting a crisp value into a fuzzy value. Here also we have considered the triangular type of functions. So we can see that a dirt level ranging from 0 to 40 is nothing but low dirt, that is 0 to 40. Here we have considered a triangular function. So from 0 to 25 it increases, and then again it goes on decreasing because we are moving away from low dirt, but we are approaching towards the medium dirt level. Similarly, for medium dirt it goes on increasing from 30 till 50, and from above 50 again it goes on decreasing as we are approaching towards the high dirt. Similarly, for high dirt it goes on increasing from 60 to 90%, and from 90 to 100%, it will not make much difference because 90% is also very dirty and 100% is also very dirty, so it will not make much difference in the output. So we have considered it to be a straight line, and beyond 100% it is nothing but a straight line. So our range is between 0 to 100%. This is nothing but the fuzzification for our dirt level. Here we can observe that what we have done is, let us say that if our weight is 10 kgs, the fuzzy value for 10 kgs is, we are approaching here, and then it will come to that like this. So it is 0.25. So in this case also, if the dirt level is 25%, it goes up. So if we just plot it on the y-axis, so it comes here, and from here it comes to 1. So for 25 the fuzzy value is 1. For 30 if we just take, it is 0.75, and for 40 it is 0. Similarly for 50 it is 1, and for 70 it is 0, and similarly for 90 it is 1, and for 100 is also it is 1. So this is how we are converting a crisp value into a fuzzy value. Next, we are going to select our output, that is nothing but time for washing. We need to convert our output parameters also into a fuzzy values. So time for washing what we have taken is 0 to 60 minutes. The time for washing is also categorized into three parts, that is low time, medium time, and high time. The term sets for these are nothing but TL, that is T stands for time and L stands for low. So low time, medium time, and high time. The time range what we have selected for the entire washing period is 0 to 60 minutes. So low time is categorized again to 0 to 30 minutes, medium time is categorized in 20 to 50 minutes, and high time is also categorized in 40 to 60 minutes. uh, we should always take care that whenever we are designing any fuzzy systems, we need to go ahead with the overlapping type of functions only, because when we take an overlapping function, there is a what we are going to do is we are not going to miss any of the values. If we directly take like this 0 to 30, that is low time, and high time as 30 to 50, any value, if the input value comes at 30, the system goes into a dilemma, or it goes into a dilemma whether it is lying in low time or medium time. So we have to always see that no values are on the borders, everything has to be on a overlapping functions. uh, so here also what we can see here is we have used a triangular type of function. So low time ranging from 0 to 30, triangular function, so it increases and again decreases. Similarly medium time and high time. Next, Next is nothing but the rule base. So whatever input and output parameters we have selected, for that we need to design a rule base. So rule base are basically if then and if then else rules. In this case we are going to use only if then rules. So we have designed a rule base for this thing. Here it is nothing but the dirt level. So this is nothing but it is represented in terms of a matrix form. So this is nothing but low dirty, medium dirty, and highly dirty, and low weight, medium weight, and high weight. So and the internal part are nothing but the times. So the rule will state like this: if the dirt level is low, if the dirt level is low and weight is low, weight of the cloth is low, then the time required for washing will be low. Similarly, if the dirt level is medium and the weight is low, then the time required for washing will be medium. If the dirt level is high and the weight is low, in that case the time required for washing will be medium. Similarly, low dirt, medium weight, the time required will be medium. Medium dirt, medium weight, time required will be medium. Highly dirty, moderately medium weight, in that case the time required for washing will be high. So low dirty, high weight, time required will be medium. Medium dirty, high weight, time required for washing will be high. So if the clothes are, so if the dirt level is very much high and the weight is also very much high, then the time required will be high. So time required for washing will be high. So the rule will state like this. We'll just take for this one: if the dirt level is high and weight of the cloth is high, then the time required for washing the clothes will be high. Is it okay? Fine. Next, in order to continue with the problem, we need to assume an example. So let us just consider one example. Let us say that the weight of the cloth is 4 kgs and the dirt level is 50%. So let us just come back to the input and output parameter. So the weight what we have considered is how much? 4 kgs. Okay. So 4 kgs where it is lying. So if we just see here, 4 kg is coming in the band of medium weight. It has a fuzzy value of 0.75. So 4 kgs is lying in the band of medium weight. Okay. Next, dirt level. How much dirty we have considered? We are assuming that the dirt level is 50%. So 50% is also lying in the medium category. So you can see here it is lying in the medium category. So dirt level is medium. So again we'll just come back to our rule base. So from the diagrammatic from the figure we have seen that our weight is lying in the medium band and dirt is also lying in the medium band. So if weight is medium and dirt level is medium, then the time required will be medium. So that is what we have done now. Time required will be medium now. So this is what is the entire, this is what is we are going to have, we have selected the problem now. So let us just come back to the diagram. So weight is how much? 4 kgs, that is lying in the medium. Dirt level is 50%, it is also lying in medium. So according to our rule base, if dirt level is medium, weight is medium, then the time required for washing will be medium. So this is how the medium block is selected. Now what we have to do is the entire triangle will be selected based on the value. So what we have to do is the weight is selected here is 4 kgs. So 4 kgs it will cut here and then it is projected on the output domain. Okay, here. Next, 50%, then again it is projected on this triangle, and wherever it is cutting from here it is projected on the output domain. So why we are projecting it on only on the medium? Because according to our rule base, we are saying that if the weight is medium and dirt level is medium, then the time required should be medium. So we have to target only on the medium. So low and high will not be considered. So this block is considered, wherein after projecting, the area of the triangle will be selected. Now depending upon these values, the alpha cut for the triangle will be given. Suppose that, let us just take in this case what has happened, this has been projected on this triangle and this is also projected on here. So out of these two lines, whichever is the maximum point, that will be considered as alpha cut. Okay, for example, let us say that my weight was 4 kgs and dirt level was 40%. So in this case, so in this case, okay, suppose that if it was only 40, fine. So now what would have happened is this would be projected on this part, okay, and then it will be projected from here to here. Now in the earlier case what has happened is this was projected here, this was projected here. Now out of these two, the maximum value was this one, so the entire triangle came into picture. But in this case, now what has happened, this has been projected on this triangle, so this value, and this has been projected on this value, so 0.75, and let us say that this value is 0.6, which is the higher value, 0.75. So our alpha cut becomes the highest value, so 0.75. The triangle which will come into picture is this one. Now sorry, so the triangle which will come into picture is, so this will be the triangle which will be coming into, so the triangle which will be coming into picture is this one. Okay, so the area which will come into picture is this one. Just show you. So this will be the triangle which will be coming into the picture. So it depends upon the value of cutting. So in the earlier case, what was happened is our value is 4 kgs, so which has been projected on this part, and then 50% from the dirt level which is projected on the median. So alpha cut becomes equal to 1. So in that case, the entire triangle has come into picture. But let us say, as we gave a second example, if it was 40%, then it would have come to something around here. From here it would have been projected, that is nothing but like this, sorry. So in this case, the two values are nothing but zero point 0.6 and 0.75. In that case, the highest value will be selected as your alpha cut, and only the triangle, this triangle would have come into picture. Okay, so let us just move ahead now. Okay, so this is how this triangle has been selected. So the rule that has got executed in the inference engine is, if W is, so that is weight is medium and dirt level is medium, then the time required for washing is medium. Now this is nothing but the inference engine what is been used is called as a Mamdani clipped inference engine. Okay, so the method what we have used is basically a Mamdani clipped inference method, so that is why we have got this kind of triangle. Now this output is sent for the defuzzification block. So now you can see this triangle has been taken from this portion, so this entire triangle has come onto the picture. So this is what we have considered here. So the range is between 0 sorry 20 to 30, 20 to 50. Peak value is at 35. Now we can apply any kind of defuzzification method which is applicable. Now the applicable method, so there are n number of defuzzification techniques which are applicable. out of which we can just see or what we can say is there are four methods which are applicable for this kind of shape. That is nothing but center of gravity, height method, first of maximum, and last of maximum. So when we solve all these methods, so here we have one which we have already solved. So we can see here this is the triangle which has been selected, and then uh, we have applied a center of gravity method for this thing. So for AB, first nothing but this section we have considered a straight line equation y is equal to mx plus c. Then we have solved for the entire AB BC using this method here. So we can see here y is equal to mx plus c. This is the same method which we have learned in the class also. So this is nothing but the slope y2 minus y1 divided by x2 minus x1. So by solving all this thing using the center of gravity method and then inserting this into this formula, integrating it with the limits, we get z star. That z star is nothing but the defuzzified value as 35 minutes. Okay, similarly if I apply height method is nothing but the peak value whichever it is in the, that is the maximum value in the entire diagram will be selected. So peak value is nothing but this one, and corresponding to this value will be nothing but 35. That is nothing but the defuzzified value. So from center of gravity also we are getting 35, and from height method also we are getting 35 minutes. Then we will apply first of maximum. First of maximum is the first maximum peak. As there is only one peak, the maximum value will be the same peak, that is nothing but 1. So the value corresponding to that 1 is 35. And last of maximum also, there is only one peak, so last of maximum and first of maximum values will be same, that is nothing but 35. So from all the techniques we are getting the value as same. Now the remaining technique, that is nothing but weighted average method, then middle of maximum, these methods are not applicable because there is no flat function available. So as there is no flat function available, that method, those methods cannot be applied. So after applying all these methods we will be getting it like this. So z star from center of gravity is 35, height method 35, first of maximum is 35, and last of maximum also 35. Now thus the conclusion what we can say is, if the weight of the cloth is 4 kg and the dirt level is 50%, then the time required for washing the clothes in order to get the clean clothes is 35 minutes. So this is how we solve this problem, and this is what is the complete thing. In order to make you understand a few more parts, so we have just taken one more simple example here. So I'll just show you one thing. Let us say that your input was, let us say that the weight of the cloth is 2 kgs. Okay, so if it is at this point, so you can see here 2 kg is lying in both parameters, both. So 2 is in the range of 0 to 3 also, and 2 to 5 also. So it is lying in the category of low weight and medium weight also. So in low weight it has a membership degree of membership as 0. Okay, sorry, in medium weight it has a degree of membership of 0, whereas in low weight if I just consider here, it is something around 0.75 or zero point 0.8. Okay, so if my weight is 2 kgs here, it is 2 kgs, and let us say that uh, dirt level is 90%. Okay, so 90% is lying in the category of high weight. So 90%. Now, so what we can see here is this is lying in low weight and this is lying in highly dirty. So according to the rule base, low weight and high dirty, we will just see here according to our rule base. Okay, so weight is low, so weight is low and dirt level is high. In that case the time required for washing will be medium. Okay, similarly, if we consider the weight to be 6 kgs, now 6 kg is lying in the category of high weight, and let us say that dirt, let us say that the time required, sorry, let us say that the dirt level is also 90%. So in that case, this is also lying in the category of high weight. So according to our rule base, weight is high, dirt level is also high. In that case, the time required for washing will be high. Now the area which will be selected for our computation will be this area, this part. And then depending upon the clipped inference, so as we have taken weight as 6 kg, 6 kg is again coming here, then it will be projected on this part, and then it is 90%, again it is coming, so the entire triangle will be coming into picture. So if we apply weighted average method, or we can apply center of gravity method and get our respective answers. Yeah. So thank you everyone.